All right, welcome. This is the first talk of day 3 of the iRODS User Group Meeting 2020. This is Kory Draughn. He's going to talk about the HardLinks rule engine plugin coming from the iRODS Consortium. You go, Kory.
Thanks, Terrell. Hey again, everybody. Like Terrell's already said, this is Kory, one of the core developers for iRODS, and I'm just going to talk to you about this new rule engine plugin that's being introduced with 4.2.8. So why did we make this new rule engine plugin? Well, it simply comes down to this issue here that's posted. Essentially, there was a user or there's a case where with NFS rides, users were trying to use basically WinSCP to transfer files. And through this, we learned that there's possibility that applications like WinSCP will attempt to do things using hard links. So in this case with WinSCP, it was trying to do renames after transferring a somewhat of a large file. And so in order to solve that, what we set out to do was we wanted to provide a generic solution for the community and future projects instead of doing something that was very specific and would only work for NFS rides. So before we get in, so now that we know the reason behind it, we now need to know what exactly a hard link is. If we're looking at Linux, then essentially Linux consists of iNodes, which hold all file information and except the file name. So, and that's important to know because in Linux, a hard link is essentially a mapping between a file name and an inode. And what this enables in that system is for iNodes to have multiple names. So how did we go about representing this in iRODS? So like we said, based on the Linux environment, we wanted to try and maintain a lot of those same characteristics. And the way we went about doing that in iRODS is through these this list here. Essentially, all affiliated data objects will have different logical paths. All data objects will point to the same replica, and all the data objects in that hard link group will share the same hard link metadata. The most important pieces of information within that metadata are the value and unit fields. The value will always represent will have a value of a UUID, and the unit will represent the resource ID at which that replica resides. And this is important because the UUID and the resource ID are used to they're there to uniquely identify a hard link replica. This also means we get the benefit of maintaining the property that hard links within iRODS, well, data objects can be part of multiple hard link groups. So now that we know how we want this to work, or at least what properties we want to maintain, we have to look at what PEPs are involved with making this work. Essentially, it just comes down to just basically watching the replica information. If replicas, anytime a replica changes, we have to make sure that we update things associated with that replica. So in the case of hard links, there's operations such as rename, trim, unlink, and file move. So far, these have been the PEPs that we've identified that need to be handled for hard links, which is great. We don't have to touch every PEP in the system to make this go. But what we realized during the development of this is that looking at the 4.2.7 rule engine plugin framework, it didn't have enough capabilities to make this work. And so what we did was we had to introduce a new instruction to the rule engine plugin framework called rule engine skip operation. And what this does is it instructs the rule engine plugin framework to skip everything following the pre-PEP. This instruction only works from pre-PEPs as well. It makes no sense to be used in post or accept or finally PEPs. Only the pre-PEP. This makes sense only in the pre-PEP situation. This being able to skip the operations also enables PEPs, the pre-PEP, to basically change the behavior of iRODS, which is exactly what we want with hard links. And finally, what this thing does is that finally PEPs and accept PEPs are still triggered, even though post PEPs aren't. So now we're just going to go through a few examples, basically involving all of those PEPs and what you can expect if you were to use this. So this first example is just going to cover on how we create a hard link. So with the, like, if we look at the very top up here, we have our key, which denotes basically circles will be recognized as data objects, and replicas will be recognized as squares. So here is our initial state, and on the right, we always have our ending state. So in this example, we start out with a data object that points to a single replica. And when we create a hard link, what ends up happening is that we have basically two logical paths with data objects that point to that same replica, as we can see, that's denoted by these links here. And we can look at these links as being the hard links to that replica. So in the case where, so there's two scenarios with creating hard links where that we have to handle. There's the case where there's no hard link metadata, or essentially the data object is not hard linked. And so in that scenario, what happens is the rule engine plugin will look at the data object and say, is this already a hard link metadata, hard linked replica? If it is not, then it will generate new metadata and attach it to the source data object. And it will also basically it will register that replica with the new hard link name and attach the metadata to that name, to the new logical path or data object. This also means it copies all permissions from the source data object to the newly registered data object. So yeah, that way people who are using this, the permissions that they had on the original source data object, they can still manipulate the new hard link data object as well. So now we want to look at this example about renaming a hard link. And what essentially happens is on a rename, we only touch the logical path for the data object. So if we look at, in this example, we want to rename this data object here. And all that happens is we end up all we do is shift the, update the name of that data object in question. The metadata and the physical path are never touched. So how about unlinking a hard link? When it comes to unlinks, this was a bit more tricky because there's more things that we have to do to make sure things, the metadata is kept up to date. So in this example, we have two replicas, we have and three logical paths. These logical paths or these data objects they each reference a single replica, except for the middle one. The middle one shares links to both the replicas. So this data object is a member of two hard link groups. It shares metadata with this data object as well as this data object. And on an unlink here, in this example, we want to unlink here. On an unlink, normally what happens is iRODS will just basically delete all of the replicas underneath that hard link. In a rule engine, in a hard links scenario, what's going to happen is you end up with basically this data object just essentially being unregistered. And so what you're left with are just the two data objects on the edge, this one and this one, and they point to the replicas that were originally hard linked. It's also important to note that on an unlink, or basically in a situation where the rule engine plugin has determined that a hard link group only consists of one data object, all of the metadata is removed. So hard links they always consist of at least 2 data objects being part of that group. So how about trimming a hard link? In this example here, we're going to trim replica 2 of this data object. Again, in this example is very similar to the last one in that we have 3 logical paths that share multiple replicas. And so what we want to do is during a trim, what you end up with is essentially we remove 1 link because the rule engine plugin knows that there are two data objects pointing to that replica. And so what it does is it looks at that and it says, okay, all we really have to do is remove this. And once that happens, we're left with 1 data object, that being this one here pointing to replica 2. We can see that here. And so because of that, we're now left with with the hard link group of size 1, and therefore the metadata for that hard link, or the hard link metadata is just removed from this data object as well as this data object. So now this data object it shares hard link metadata with just this data object here. Last but not least is the situation where people can use ifmove and to physically move a replica from 1 resource to another resource. And if we think about it, the only thing that happens here is just, as I just said, the replica is moved from 1 resource to another resource. So this is just a matter of updating the hard link metadata for all of the replicas or all of the data objects to reference the correct resource ID. Remember, the resource ID is stored in the units field of the hard links metadata AVU. And so ifmove is a very simple case where we just have to go through and we have to figure out what's the resource ID of the destination resource and essentially just update all of that metadata to reference that new resource ID. So some important things to know about this rule engine plugin are, unless you've been instructed to, hopefully if everything is working properly, you won't have to do this, but you should try your best not to modify the hard link metadata directly. You should let the rule engine plugin manage that. Of course, there are situations where people can, where a system can fail. And in those cases, obviously someone has to go in there and correct things. We're working to provide tools that will help with this case and make it easy for you to handle. Another thing is, once you create a hard link or hard link data objects, the information, well, you can never get back or figure out from the hard link metadata who was the original data object that referenced that replica. So at that point, all of the data objects will look as if they just existed that way. They won't know, oh, I'm not the original owner of this replica. Another important feature, another important thing to note here is that post PEPs will never be triggered when when the rule engine plugin has determined that a hard link has to be manipulated. So again, we have to think about the rule engine skip operation, and that when this skip operation is returned, the actual operation and the post PEP will never fire because hard links is overriding that behavior. And this has some important ramifications that I'll discuss on the next slide. Last but not least, finally PEPs are always triggered, as well as accept PEPs if exceptions are thrown or if an error occurs. So unfortunately, this thing is hard to write and implement. And so there's a case that we have not, that we need to go back and handle and rework. And because of that, it's likely that you won't want to use this in a production environment. It's okay to test it out and play around with it just to get a feel for it. But essentially what's going on here is because the rule engine plugin skip operation causes the post PEPs to never fire. In the case of a hard link, This means that any post PEPs that you have that you've written and you rely on, this will not work well with other rule engine plugins, such as, for example, logical quotas or the M-time rule engine well, possibly the M-time rule engine plugin, but essentially we have to go back and determine what we want to do about post PEPs with this rule engine plugin. So you can look forward to seeing updates and a fix for coming in 4.2.9. So here's my last slide, and what I have here, you can find the repo as well as the RFC that was written that led to the development of this rule engine plugin. Thanks, and questions.
Very good, Kory. We did affectionately begin to call these diagrams that Kory showed Conway diagrams after our friend and colleague, Mr. Mike Conway. So I don't think he's here to defend his honor. So if he would like to say a few words about that, he could. I do have a couple questions. We've got a minute or two. John from the University of Groningen, does a hard link only link a data object to a single replica? What about other replicas? And what about the possibility of hard links to other data objects? So you've answered the first piece of that, I think with the diagrams. What about the possibility of hard links to other data objects?
The rule engine plugin does not handle that case right now. It's only the relationship, it deals with the replicas. So the hard link, you can think of it like the metadata is attached to the data object, which tells the system which replica is hard linked.
That's right. And a link to another data object would be similar to a soft link or a symbolic link in the operating system level. So I think that answers your question, John. Martin Kuhnen from Maastricht. Can the hard link functionality be used for deduplicating data in data collections, i.e. create a new version of a collection and hard link all the data objects that are the same as in the previous version of the collection?
Hopefully I can answer your question correctly, but and maybe we need to talk about this offline. Sure. But the rule engine plugin only handles data objects, replicas. I think what you're asking would involve a bit more investigation in code and see where that fits in regards to this current implementation. But I can't say exactly right now.
Yeah, I just quickly off the top of my head, I imagine that if there was some checksumming or something involved, then yes, two logical paths could point to the same replica, which is what this is. And yes. So you could have a second collection that's very similar to the first collection, and all those items point to the underlying objects. It would be probably not fast because that's a lot of metadata to move around very quickly. But I imagine that there could be some code that could be built to do that. Josh Moore asks, perhaps the same question for S3. What's the interaction between hard links and S3? Could this provide the possibility to have two S3 paths to the same underlying blocks?
Well, because we're dealing with logical and the physical, all of the logical paths can share, they can point to the same replica, which could exist in S3. So right. That should work.
That's right. We have not tried that. That's correct. Right. But I don't see any, there's no break in the abstractions here for that, Josh. Right. And I believe that is the end of the questions I see in Slack. We are 1 minute over. So yes, if they've got more questions, we'd be happy to talk more about this. We do know there's a little bit more work to do to come up with some of these, to fix some of the edge cases, but we're pretty happy with this implementation so far. And it does work with NFS rods at the moment. Yes. That's what it was designed for. Thank you, Kory.